Hi, I'm Lars. Welcome back to the C# workshop. Strings are the most used reference type in computer programming. And I find that extremely important that a developer understands how they work. After this video, you'll understand a lot about strings, not everything, but for sure you'll know how to properly use them. There will be a deep dive in strings in the videos after this little series, but that there I would definitely watch. If you have to use strings a lot for your job, look for that video when I get it out. Have you ever wondered who wrote the first virus? Then stick around and let's get to it. Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. So to show this in C# is pretty easy. We initially are going to add a value type in here, and it's going to be a char or a character. And the way that you add characters to assign them, they go in single quotes. If they were in a double quote, the compiler would think this is a string trying to be assigned to a char. And I'll show you why that's a problem. Traditionally, what we call a string today was a character array. And we're going to put this under first name like this, and then we're going to initialize it like that. So this is an array, just like this is a CH. This will be a character, a character, a character, and a character, just like it is. And this would be position 0, 1, 2, and 3. Now, if we print out console write line, and we do CH, and we print out console write line first name. So let me make these a little prettier. CH colon plus, and we'll put first name colon plus, and we're going to run this. As you can see, CH produced the L, but first name produced system char array. Now, the reason that it did this is the CH is actually a value type. So this value type is actually in the same address as where the data is. Now remember from the drawing, the character array first name is not. It is actually a pointer to the real data. We are not accessing the real data at this point. We are accessing this variable, and it's telling you it's a system.char array. One way that you could print this out is you could come in and you could put 0 and then put a plus, 0 and then a plus, and then you could put a 1 and a plus and a 2 and a plus and a 3. And then we could run this, and you will see that we get first name Lars, because these are accessing these memory points right here where these are sitting. Now this is not really beneficial here, just because what if I put my full name in here as Lawrence, then I have to go and redo all this work. So what people used to do is we used to knock all this stuff out of here like that, and we'd make this a right, and then we would add a for loop in here. And just like, the normal for loops, I is less than the first name of the length, right? The length of first name, and you're going to increment I. So AI is going to want to come in and help us out a little bit. It almost got it right. We just need a write statement here. And then down below we put a curly bracket, and then let's put a console write line in so that we don't have this sticking on the end. Now let's run this. So now we get CHL and first name Lars. Now this makes sense, all right? Because now you're just writing out first name here, and then you're accessing each individual memory location for L, A, R, and S. All looks good. Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime. So as you can see, this was kind of a pain in the butt to do. So someone decided, I don't know when this was, but someone decided that we should create an object called string, and it basically would hold this char inside of it. And so let me replace this now. So it would hold this char inside of it along with some other data. The data like the length of it, is it empty, is it not empty, just things like that, some stuff that you would need to know. But now I can come in and I can say Lars, and now I got a string. Okay, I don't need to do this for loop anymore. I can just put a right line here, come to the end, and this object will actually take care of iterating this out on its own. So now let's run it. And look at that. Same output, but a lot less code. Now, is that code being put in the machine language? Of course it is. But it's less code for you to understand and to learn. This is something that not many developers know about. So take this to heart, because if you understand this, then you'll understand the next thing I'm going to tell you. And the next thing I'm going to tell you is if I have another string here, and I'm going to call this, first name 2, and I assign this to first name. Now remember, string is a reference type, because you just saw how the array was built for it. So you know it's a reference type. So in your mind, you're thinking it's a reference type. It works just like the arrays. First name equals Lars. First name 2 is going to be pointing to first name. So let's write these out. Let's put first name 2 here, first name 2. We really don't need the character anymore. I'm hitting Control L just to delete the entire line. And let's run this. And again, they equal each other. So let's take first name 2, and let's set it equal to Lawrence. Now, from your experience with reference types, first name should also display Lawrence. However, it doesn't. Strings are what are called immutable, and that means every time that you change one, you're going to create a new one. So let me get rid of first name 2 here, or just move it aside. If I was to take and I was to say first name is equal to first name plus, and then put Thurman in here, all right? This will create a brand new string, a brand new array of characters, and it will say Lawrence Thurman, and this is going to be still sitting in memory. The next thing I want to talk about is the difference between null, a null string, and an empty string. So if you have a string, we just put the word value here, it's common, and you put string.Empty in it. This means you have your pointer, okay, you have your address, and this guy is pointing to an actual array, and that array has nothing in it. Okay, there's this address is there, but there's just a 0 in it. You can't see it, you never will see it. It's just empty. And then there's the difference is the null. Because being that this is a reference type, you can put a null in here. Now, this is something I'm going to talk about here. It says converting null literal or possible value to a non-null value type. This error is totally, well, it's not totally bogus, but 99% of you that are writing code are never going to come into this condition. So what I do is I go into here and I turn nullable to disabled. I think this should be disabled by default, and if you need it, then it should be enabled. And that will get rid of this error here. Okay, string is a reference. It can be nullable. So what this is doing is this is saying the string value is no longer pointing out to the memory address that you have sitting out there. So the char that's inside of it, the char array, gets set to null. And that's all this does. It says there's nothing here, you can't touch it, we're done. Now, why is this important? So let's go back to Hello World. And if I build a conditional here and just say if value is not equal to null, okay, right line value. Let's run it. Hello world. And that's because we can all see value is not equal to null. Now what if value is empty? Still not null, but it's empty. And this here knows it's empty. So we actually put out just like that. It's just an empty line. Just looks like that, Okay, we're going to put value back in here. This is great. And then there's another thing here you might want to check. Maybe you don't want to see it when it's empty. So you're going to say when it's not equal to string.Empty. Okay. And you run that. And then there will not be a gap. See? The gap's gone. There is a value that is inside of string that will override all this. If you type in the word string and you hit dot, you'll see is null or empty. And you will also see is null or whitespace. Now, what's the difference? Now, I'm going to show you one more thing here. That's whitespace. We don't have a test for value not equal to string dot whitespace. All right, it's not there. You could say value dot trim, which would check the trim, and say if that's not equal to this, and then that would work, because trim will remove all of the space, all of the blanks on either side. There's a left trim and there's a right trim. So this will not print anything. Or you could save all these ands, and use something that's a little more readable. And there's the is null or empty. It'll take care of these two. And the statement says right here, if you read it, says indicates whether the specified string is null or an empty string. True if the value parameter is null or an empty string, otherwise it's false. So if it had spaces in it, you're still going to get past. But you could say null or whitespace, and now this one says if the string is null, empty, or consists of only whitespace characters. So you can say if null or empty, and then put the value here like this, and then all of the rest of this can go away. And now you're not essentially, you're saying everything. So the way this is read is this says if the string is null or whitespace, then print it. We don't want that. We want to say if not. If the string is not null or whitespace. So if this is false. Now you could also come in here if this makes you a little queasy. You can say is equal to false. All right. But in the professional world, you're going to see more of this than you're going to see the other one. So just get used to putting the bang or the not in front of it. Now, if we run this, it works just fine. So if we put something in here like hello world, and we run this, it will work. Let's say hello world, just like that. Say we're sticking with an empty string, and you're going to say value. Now there's two ways to concatenate strings, and one is to just put in hello world, hello. I'm going to do it like this. Hello world, like that. There's another way you can do it, and they both work exactly the same way, except this has string concat in it, and these all get separated by commas instead of plus signs. Is one way cleaner than the other? I don't know. I don't think many people really use the concat. I usually see people adding them together if they're gonna go down something like this. There's also another, if you have data that you want to put in here, all right, and it may change periodically, but say you have an integer, and it's called number, and we're going to set it to the number 6. You can also take and concat in the number like this, and concat will run it the same way. So let me just throw all this out so that you can see it all working together. And these two will come out exactly the same. Okay, 6 hello world. There's no space in between because we didn't put one, so let's put the space in here like that. Once you get these set up, you can add a space. You can add a space here so that you get the space between the number. There is another way to do this, and this is using a string.Format. I'm just going to add hello world here just as one string, and then I'm going to add a number at the end. And we can print this off too. And you will see all of these work the same. Let's talk about escape sequences. And escape sequences are kind of cool. Sometimes they can be a pain in the butt. But say you want to put a tab in between two words. Like say you say hello and you want to put a tab. You put a \T. You put world. You notice the \T change color. Okay, so when you run this, the hello world will be spaced apart with a tab. And that's whatever your default tab is. It's not your programming tab. You can also put in here a carriage return. That's what that is a carriage return. And if you run this, you're going to lose the hello. The \N is a line feed. For a screen, you can just put a \N in if you just want to come to the next line. However, if you do this on a printer, you're going to end up with something that looks like this. And this actually happened to me back in the 80s. And I had a long discussion with a senior engineer that argued my point forever until I finally got him to put a carriage return line feed in, and then this actually moved over. But he burned through reams and reams of paper. So if you're doing something that needs to be printed to a printer, make sure you put a \RN. There are a lot more of these. I'll put a list of the most common ones that you're going to need to remember in the description. Now, being that we have escape sequences, if I was to put this in here, I am going to get an error, right? Because it doesn't know what \D is, because this is reading this as an escape sequence. Now, a lot of times, someone will do this and go, oh, yeah, that worked, and they'll just keep on going. However, then when they print it, they're like, where'd my D, oh, and then they realize. So escape sequences, there is one for a \/ also. If you need to put a \/ in, put 2 backslashes, or what we call whacks. There's a group of us here in Ohio that this is a whack and that's a slash. So it's easier to say whack instead of \, I guess. I don't know. You can also use the @ symbol, it's the Shift-2, and that is a verbatim. So that makes all the escape sequences, anything that's in between the quotes, will get printed as it is. So if you leave the \/ in there, it will come up like that. All right? And it will set that value. If you take it out, you're fine. You'll get exactly what you want, and that will be the value that you'll be able to open a file, that data file, and it will work. You put the 2 slashes in, it'll say folder not found because it's looking for D folder / data. Okay? Now, the other thing that is really cool, and when it became available in C#, I don't know if it came from another language, somebody saw it, and it doesn't really matter, is that it really changed everybody's lives. And that is string interpolation. So like you have this up here, right, with this format, wouldn't it be so nice if you could put this in here and then change this to number? And that's exactly what string interpolation does. So when you run that, you get that number. Now, the reason this is so great and that this is not is if you have another one of these in here, like a 1 and a 2, and let's add number 2 and number 3. We'll call this 7 and 8. Now, this will work out lovely. Not want number 2 there, you want number 3. and we'll run it, and you will see 6, 7, 8, hello world, which is fine. The problem you have is when you want to take this one out. Okay. So imagine having like 50 of these that you're trying to do this with, and you go to run this, and boom, now you've got an error. And you know that you took one out. The problem is here is that this did not get changed to 1, and it's looking for position 2, because these can be out of order. So let me rerun that with just the 1 there. And you'll see you'll get 6 and 8. So there is some issues with this, okay? So you could put in here at 2, and you could put number 2. And it will print out 0, then it will go to 2, then it will come back to 1. All right? Just for your knowledge. If you were to have this down here, and you had number 2 and number 3, and you decided that you didn't need number 2, you just take it out. A lot less issues with testing your code. You just got rid of it. You still need to test it, but you got rid of it. I've got some more stuff that I'll show you in a few videos from now when we start talking about ternary operators and stuff like that, about how cool these things can be. Okay, one last thing. And we're gonna get rid of all this here. And I'm gonna put value in. And that is called raw. If you put 3 of these in, whatever you type in here, and you put a semicolon at the end, it's got to be at least 3. You could put 4, it'll just go to 4, 5, 6, 7, 8, 9. And the reason being is because you might have quotes in here. So say I put a quote here, hello world, like that, it'll understand it. So this is called raw, R-A-W. And look how cool that is. I must have typed an E up here at the top. I did. Look at that. So this is something that is very powerful. It's new to it might have just came in .NET 9, but this here I'll be using a lot of. They just say you need at least 3. So for some reason, like if you needed hey, we're going to put, I'm going to put 3 quotes around this. Well, you got a problem, so just put a 4th up here. And you put a 4th here, and you get rid of that one, and this will work just fine. You just need at least 3 double quotes. You can use as many as you want. You can put in whatever you want. So, very cool in my mind. So that's something else besides the string interpolation that I thought was really cool.
Thanks for watching this video. Please like and subscribe to the channel. I really hope you enjoyed this video and understand a bit more about reference types and how they work in memory. A very important thing to understand is there are a lot of reference types. In fact, they're unlimited. There are user-defined reference types, which are things like you and I make in our applications. That video is coming up and it's called classes. All right, it's a couple videos away. If you have questions, please drop them in the comments. Who wrote the first virus? A program named Creeper was written by Bob Thomas at Raytheon BBN. So this was originally Bolt, Beranek, and Newman Inc. But they got bought by Raytheon, but they still kept BBN at the end. In 1971. Technically, it was a worm. And it would print, I am the Creeper, catch me if you can. Then it would move itself to another DEC PDP-11 and repeat. Okay, so it would just copy itself over and just keep on going around. There was like 17 DEC PDP-11s in their lab. Then a gentleman named Ray Tomlinson updated the code, so instead of moving, it would make a copy of itself to the other machines. It was created to demonstrate the possibility of a self-replicating computer program. It was created to demonstrate the possibility of a self-replicating computer program that could spread to another computer. Exactly what the world needed in 1971. In 1972, Tomlinson, the same person who updated Creeper, created a program called Reaper. It was the first antivirus software that would delete Creeper from your machine. Kind of make you think about where are all the viruses coming from today. You're always welcome back here at the C# Workshop, and have a nice day.